Namaste and welcome back to the DSA classes. Today we are going to be discussing another problem called as the count of smaller or equal elements in a sorted array. Now what does this problem mean? Very simple, guys. Let us take an example. Assume that I have an array like this, okay? Now let us assume they'll give you another value called as k. K is 26, let us assume. Now if you notice, here in this array, you have to return the count of the number of values which is equal to or smaller than the given k value. Now is the given k value there? Yes, 26 is there, which means totally how many values do you have which is equal to or lesser than 26? 1, 2, 3, 4, 5, 6 values you have. So totally 6 values you have and 6 must be your output. I hope you understood the meaning of the question, right? Now how does one write a logic for this? Now to arrive at a logic for this, we have to think about different cases, different scenarios. Only then you can write robust code which will work for all kinds of input. Okay. Now what I would say is, this is my case number 1. Where if you notice, this is a sorted array and the question guarantees you that it is going to be a sorted array, okay? And if you notice the sorted array, there are no duplicates, friends. There are no duplicates in this sorted array. So the case number 1 is no duplicates, okay? Now very simple, you have to basically, given a k value, you have to tell how many values are lesser than or equal to it, very simple. So would you agree that I have to first find that element, search that element, right? I have to first search whether that element is there or not, because only then I will know how many elements are there lesser than or equal to it. First of all, I should know whether it is there or not. I hope you're able to think. So one way you can do is you can perform linear search. You can keep performing linear search, right? And you can, find that element, or you can run a loop from the beginning till the ending and go element by element and see whether it is lesser than the given k value, and you can keep incrementing a value of count. Definitely that is the easiest, most obvious way to solve this problem, but if you use that approach, obviously your time complexity is going to be big O of n, because you will have to go till the end of the array. So that is not the right way to do it. So what I would do is very simple. Look at my logic. K is 26. What if I search for 26? Now if I search for 26, yes, 26 is there. Now look at this. If this is a sorted array, would you agree that all the elements from 0 till 26, from 0 till 26 are all lesser than or equal to 26? Simple. So if I can search for 26, take its index. What is the index of 26? 5. The index of 26 is 5. So all I have to do is, 5 means how many elements? Totally 6 elements, because index starts from 0. That's it. That's my answer. Simple. Now what is the most efficient way to search for a given value in an array? You have binary search. So obviously I will apply binary search. Now that's what I'm telling. Perform binary search. Now if I perform binary search, low, high, I'm bringing up the table. Low is 0, high is 7. Mid is 0 plus 7 divided by 2, it is 3. So mid is 3. Check if the element at the third index is equal to the key that you're searching for. No. No means check if it is greater than or lesser than. Now if you notice, it is greater than. If it is greater than, it will be on the right hand side, which means adjust low. So low becomes mid plus 1, high remains the same. So low moves. Any confusion? Again calculate mid, you get the index as 5. So mid becomes 5. Check the fifth index element, is it equal to the key you're searching for? Yes, which means you found it. Great, you found it. Look at the value of mid, it is 5. How many elements are there which is lesser than or equal to 26? 6 elements. How can I make that 5 as 6? Plus 1. So would you agree? If I perform search and I find that element, all I have to do is return mid plus 1, and that is the count of the number of elements which is lesser than or equal to the given value. I think everybody would agree with me on this aspect. Any confusion till here, my dear friends? I hope everybody has understood. Correct. Yes, we understood, sir. But this is the problem. If now directly you go and write code for this, it will not work for certain test cases. Why? Let me take another case. But I hope case 1 is clear for you, where there were no duplicates. So naturally, my case 2 becomes such a case where there are duplicates. Duplicates exist. And if you notice, the array has changed, where I have 26 repeating 4 times. So my dear friend, my question to you now is, if k value is 26, How many elements are there which is lesser than or equal to 26? Actually, there are totally 8 elements. There are totally 8 elements. But if you use the previous approach, then you will not get the right answer, because the first occurrence of 26 will match. It will match, and then you take this index, which will be mid plus 1 you will do, which means you will tell 6, but actual answer should be 8, because there could be duplicates. So would you agree you have to check? Would you agree you have to check for duplicates? Correct, sir. How would you propose we do that? Simple. First and foremost, you perform binary search. Okay, you perform binary search. Now, if the key is found, then directly don't return mid plus 1. Don't do that mistake. Mid plus 1 is outside. Don't do that mistake. If key is found, now I would like to check for duplicates, because that count is also important for me. I have to check for duplicates. Now the question is, sir, how will you check for duplicates? It's very simple. First of all, let's perform binary search. Okay, low, high, 0, 7. 0 plus 7 divided by 2, mid is 3. Third element is 18. Obviously, it is not equal to the key. Key is greater, which means I'll adjust low. Low becomes mid plus 1, 4. High remains the same. 7 plus 4 divided by 2 is nothing but 5. So I will come to 5. It's equal to the key. If it is equal to the key, I found the key. Now that I found the key, I should now check for duplicates. Now very simple. How to check for duplicates? I am showing you. It's very easy. To check for duplicates, would you agree? I am here. All I have to do is, from here, I should keep going to the next element, and keep checking whether the next element is equal to the key. Whether the next element is equal to the key. Whether the next element is equal to the key. I have to keep checking like this, and I'll go till the next element that I'm checking for is not equal to the key, or I have gone outside the boundary of the array. Would you agree with me? So see, very simple. What I will do is, the moment this condition is matched, inside that I will apply another loop. Wherein I'll tell while. While means what? As long as. As long as the key is equal to the next element also. Next element means mid is here, m is here. M plus 1. I hope you're able to think. Is key equal to a of m plus 1? I will check. If that is the case, what I will do is, I will take this mid value and I will increment it. M plus plus, or mid plus plus I will do. Any confusion till this point of time? Why am I incrementing it? Because ultimately our logic is what? Whatever is the mid value, whenever the key is found, that plus 1 only you are returning. But that mid value has to now also take into consideration how many duplicates are there. So just increment the mid value. So now mid value will go to the next one. Now check if the next element is also the same. If it is the same, again increment mid value comes here. And now if I check whether the next element is also equal to the same, then I will go outside the boundary of the array. And I will be trying to access an index which does not exist. And whenever you try to access an index of an element that does not exist, you will get array index out of bounds exception, or list index out of range exception in the case of Python. You will get exception. So to avoid that condition where you may go outside, you may check for an index outside the boundary, make sure in this while loop, before checking whether the key element is equal to the next element as well, first check whether the next index that you are going to check for exists or not. How will you do that? Simple. I'll push that condition inside and I'll add another condition where I'll check as long as m plus 1, I'll check the next index, m plus 1, is it less than the length of the array? You know the length of the array is 8. If it is less than the length of the array, you know it is one of the valid indexes. I hope you're able to think. And if key is equal to the next element, I hope you're able to think. Only if both conditions are satisfied, I will increment the value of mid. I hope you're able to think. So this ensures exception does not occur. So did you understand the second case where duplicate exists? So perform binary search. If the key is found, check for duplicates. then come outside and return mid plus 1. And as you know, mid value is here, mid plus 1 if I do, 7 plus 1, 8, and you know there are 8 elements. Correctly it works. Correctly it works. So do you see in how many different ways we can be using binary search? That's why I told you it's one of the most commonly used algorithms out there. Great. This also we understood. Next, what you may ask. Now, if you think that you have thought of all the cases, you, my friend, are absolutely wrong. Sir, is there one more case? Yes. First case, we checked whether that element is present. Second case, we checked if duplicates exist. So naturally, the third case will be such a case where the element does not exist. K does not exist. I am changing the array a little bit for you, and K value is now 25. Is 25 there? Not there. Not there. Now what will happen? So as of now, what was our logic? Perform binary search. If key is found, check for duplicates, and then come outside, return mid plus 1. This was our logic. Now see here. 25. Let's start applying binary search. Low, high. So low is 0, high is 7. 0 plus 7, mid is 3. Third element is 24 here. So 24 is not equal to key. Is key greater than the mid value? Yes. Yes means low has to be adjusted. So low becomes mid plus 1. It becomes 4. High remains the same. Again calculate mid. 7 plus 4 divided by 2 is 5. So mid comes to 5. Is it equal to the key value? No. Is the key value lesser than the mid value? Yes. Which means if at all it was there, it will be to the left side. So I should adjust high. So low value is the same. High becomes mid plus 1. It becomes 6. 6 plus 4 is 10 and mid value is 5, which means again I have come to the same position. Again I will check, is it equal? No, it is not equal. Then what will happen? I will check if it is lesser. Yes, it is lesser. So I have to again adjust the high value. So high value becomes mid minus 1. So high becomes 4, low remains the same. Now both low and high are equal in the same position. Again find mid. Mid will also come in the same position. So 4. So I'll come and check, is the element at the fourth index equal to the key? Not equal. If it is not equal, then I will check, is it greater than or lesser than? It's lesser than. If it is lesser than, I should adjust high value. So high becomes mid minus 1. So see, mid minus 1 means high becomes 3. Low is the same. And the moment low becomes greater than high, or you know, the high value becomes lesser than the low value, you know that the binary search condition fails. Loop termination happens. Loop termination happened. You came out. You came out. Tell me, where is the mid pointer at? Mid pointer is at fourth index. Is at fourth index. Now tell me, if I go and I return mid plus 1, I will be returning 4 plus 1, which means I am telling there are totally 5 elements which is lesser than or equal to the given k value. But in reality, how many elements are lesser than or equal to the k value? 1, 2, 3, 4. Wrong answer you have got. Wrong answer you have got. So how does one fix this condition? Directly I should not return mid plus 1. That much is clear to me, that directly I must not return mid plus 1. Then what would you be doing? Sir, if you ask me, very simple. Use observation skills. Now, if the element that you are searching for is not present, okay, what will happen is this mid value, binary search will work in such a way that it will always come to the next highest element. The next highest element only it will come. It will come there only. Hope you are able to think. So what you have to do is, if really the element is not there, and wherever the mid value is, if you can, tell mid minus 1. 4 minus 1 means it will become 3. Hope you are able to think. Any confusion till here? 4 minus 1 will become 3. So that is what ultimately that we have to return, that mid plus 1 value only we have to return. So what I would do is very, very simple. No need to even read or subtract. No need to even subtract. What is the mid value? 4. How many values are lesser than the given k value? 4. So no need to do mid plus 1. If the element is not there, the index of mid will be the index of the next higher element than the given k value. and that index is equal to the number of values which is lesser. So no need to do mid plus 1. Directly if I can return mid, it will be great. But how will you write code like that if you ask me? See, I'll come outside, directly I'll not return mid plus 1. Instead I will check if in case the element present at mid, is it greater than key? If it is greater than key outside the loop of binary search, I know that the element was not found. If it is not found, I know all I have to do is return the mid index, which will be the number of elements which is less than or equal to the given k value. How people to think? But if this condition was not satisfied, then I will tell else return mid plus 1, which is what we wrote for the last two cases. I hope you're able to think. That is what we wrote for the last two cases. So this is for returning the mid value. Now, if in case the key is not present. If in case the key is present and if in case duplicates are there, both of that, this one took care of. Any confusion till this point of time? Great. So now let me just recap the three cases for you. Case number 1, no duplicates. No duplicates means do binary search. If you find that element, come outside, return mid plus 1, perfectly, it will work. Case number 2, if there were duplicates, then the moment you find that element, within the binary search itself, also check for duplicates. For that you have this while loop. Then the mid will go till the last duplicate value. Come outside, return mid plus 1 and definitely it will work. Any confusion? So that returning mid plus 1 works if the element is there and duplicates are also there. However, if the element does not exist, then what will happen is directly don't return mid plus 1, you will get wrong answer. You have to return the mid index. So for that, come and check if the element at mid was greater than key, which means it was not there. If it is not there, just return the mid index. Otherwise, it was there. Maybe it was there with duplicates, without duplicates, we don't care. Return mid plus 1. Because we have already taken care of that here. Any confusion till here? So this is the simple algorithm to solve for such a problem. I hope everybody understood. So then what are we really waiting for? Let's go write some code. Now it's time for us to write some code. Listen, I've created a static function which returns an integer called as count small and equal elements. Okay, so it accepts your array, it accepts the key. Now ultimately you can see the main function. This is my array. Right now that I am passing, it does not have any duplicates. And the key is 26. I am calling and I am passing both of them. Now I will come here and what I am going to do there is very simple. I will now start with the binary search because that is the core of our logic. So I'll just paste the binary search logic. This is the binary search logic. I'll return that -1 and all. I'll remove that for now. Now listen to this. It's very simple. What did I tell you? That this is my case 1 array. What I should do is I should apply binary search and search whether 26 is there. If 26 is there, then this condition will be satisfied. If this condition is satisfied, what I will do is I will not come and return mid. This is pure binary search. I'll remove that. Now, this mid will be at the index of 26, correct? Now, what I will do is from here, I'll just tell break. I'll come out of the loop. I'll just break it because I want to come out of the loop. See? So the moment I find it, I'll come out of the loop. Out of the loop means here. There I will tell return mid plus 1 like this because we want index plus 1. I hope you're able to think. So minor modifications. Will this work? Let's see. If in case I execute now, you have got 6. Yes, there are 6 values which is lesser than or equal to 26. Come down. As you can notice, 1, 2, 3, 4, 5, 6 values lesser than or equal to. It works. Okay, I'll comment this, uncomment the second case. Now in the second case, duplicates are there. Now duplicates are there, so we should get 8. There are 8 values which is less than or equal to 26. But you will only get 6 because that's the way you've written code. Execute. Wrong answer. So you have to now consider whether duplicates can be present. So what will we do? I'll come back on top. So what I'll do here is, if in case I find the element, directly I will not break out. Before breaking out, I will see how many duplicates are there. You know the code for that. As long as, okay, first of all, the next element, is it also equal to the key? I'll check, which is A of M mid plus 1. is it equal to key? If that is the case, ultimately it is the mid index plus 1 that I should return. So what I will do is I will increment mid value, mid plus plus. So the mid keeps going forward. Hope you're able to think. Great. Ultimately, when I break out of this loop and I come here, what will happen is I will come here and return mid plus 1. So correctly I should get. However, if I execute, you can notice you have got an exception. You have got an exception. Scroll. Index 8 is out of bounds for length 8. So 8 is the length, which means last index is 7. But what happened is the last time you went out of the boundary, this mid plus 1 took you out of the boundary. That should not happen. So I'll go on the start and first check if in case mid plus 1, when I do, is it within that boundary? So less than a dot length. If it is within the boundary, only then I will come here and I'll apply and I'll check this condition. If both of them are true only, I'll increment it. So this takes care of duplicates. I'll go execute. If I execute, one can clearly notice correctly I've got 8. Great. Now I'll come down. Now I will just comment this, uncomment the next one. So here you can notice that the value doesn't exist. The value doesn't exist. If the value doesn't exist, what is going to happen is I will make that as 25. So now let us go and technically 25 means how many values? 1, 2, 3, 4, 5 values. 5 should be the output, less than equal to 25. If I execute, I will get 5 here, and that is because, okay, you can put some change, make 226. Okay, execute now. 5. Okay, so it should not be 5. It should be 1, 2, 3, 4 values, but you got 5. So it is a mistake. It should not work. Any confusion? So what should we do? What we should do is, I told you the logic. If in case really the element was not there, upon performing binary search, your mid index would have come to the first value, which is greater than 25, which is 26. So this, what is the index of this? 0, 1, 2, 3, 4. How many values are lesser than this actually? 4 values. So whatever is the mid index you should return. So how will you do that? I will come here and on top, just directly I will not return mid plus 1 because I want to return mid, and this should only happen if the element is not there. And if the element is not there, then the element of where mid is pointing to will be greater than my key. So I will check if in case A of array A of mid is greater than key. Have you told A or AR? Okay, is greater than key. If it is greater than key, I will return mid. Else means that no, the element was there. With duplicates, without duplicates, doesn't matter. Element was there. If element was there, then return mid plus 1. Any confusion till here? Now if in case I execute, correctly one can notice, you will get the answer as 4. So I really and sincerely hope everybody understood the logic of writing a program which is going to count the elements which is smaller than or equal to a given value in a sorted array. And how efficiently we were able to use binary search for this is also clear to all of you. Anyways, I hope you guys will go and type and practice this program. Let's catch up in the next program and solve even more exciting questions together. Till then, take care. Bye-bye.